Hello everyone, this is Divya. In this session, we are going to discuss about the data flow diagram of ARM processor. So usually ARM stand for Advanced RISC Machine. So what is the uses of ARM processor? ARM processor are designed to be power efficient, which is important for the mobile devices that are limited in battery life, and it is cost effective. ARM processor often less expensive and than the other types of processor, which can make them a cost effective choice for manufacturers. So let's discuss about the introduction to ARM processor data flow diagram. The ARM processor is a type of microprocessor architecture commonly used in embedded systems and mobile devices. Understanding the data flow within the ARM processor is essential for optimizing performance and efficiency. A data flow diagram provides a visual representation of how data moves through the various components of ARM processor. Overview of ARM processor components. The ARM processor consists of several key components, including the ALU, registers, memory interface, and control unit. The ALU stands for Arithmetic Logic Unit, which performs arithmetic and logical operations on the data. Registers are small storage locations within the processor used for temporary data storage. So this is the data flow diagram of the ARM processor. Data flow from memory to registers. Let's now discuss about the how data is flow from the memory to registers. Data is fetched from memory and in the registers for processing by the ALU. The memory interface is responsible for the transferring the data between the memory and the registers. Efficient data flow from memory to registers is crucial for minimizing latency and improving the performance. So this is the diagram for registers within a CPU. This is the data bus and it contains program counter, instruction register, program status word, and in the memory address registers it contains general purpose and registers. Data flow within the ALU. The ALU performs mathematical and logical operations on data stored in the registers. Data is processed based on the instructions provided by the control unit. The ALU outputs the result of the operation back to the registers or memory. So in this picture we can see data flow within the ALU. Here ALU provides the outputs operand 1 and operand 2. It can be passed as a result in the general purpose registers up to S0 to S31. Nearly 32 types of registers are stored in this ALU operator. Control unit and instruction flow. The control unit is responsible for fetching instructions from memory and decoding them. Instructions determine the operations to be performed by the ALU. The control unit coordinates the flow of data and instructions within the ARM processor. This is the picture of instruction cycle. From the control unit, the instruction will be fetched. It can be decoded the instruction. It can be operated in the read address from memory and it can execute the instruction from the control unit. Data flow between the components. Now let's discuss about how data is flows in between the components. Data flow within the ARM processor, it involves communication between ALU, registers, memory interface, and control unit. Efficient data transfer between components is essential for optimal processor performance. Proper synchronization of data flow ensures accurate execution of instructions. Pipelining in ARM processor. Pipelining is a technique used in the ARM processor to improve by allowing multiple instructions to be processed simultaneously. So usually a single instruction is difficult to pass for the processing from the control unit. So we are using the pipelining technique to pass the instructions for the processing. And data is flow is segmented into stages to enable parallel processing of instructions. Pipelining helps maximize the utilization of the processor resources and enhance its overall efficiency. So this picture shows the 3-stage and 5-stage pipelines. It includes pipelining, ARM7 3-stage pipeline, ARM9 5-stage pipeline. Data flow optimization techniques. Usually we are using two different types of techniques to optimize the data flow in the arms. Let's discuss what are the two techniques. The techniques such as caching and branch prediction are used to optimize the data flow in the arm. Caching means catching involves the storing frequently accessed data in a fast memory for quicker retrieval. Prefetching anticipates data needs and fetches them in advance to reduce latency. Impact of data flow in performance. During the performance of data flow, what are the impacts are happened in the CPU is shown here. Efficient data flow within the ARM processor directly impacts its performance and efficiency. Bottlenecks in data flow can lead to delays in instruction execution and reduced throughput. Optimizing data flow through proper design and utilization of techniques enhances the overall performance of the ARM processor. This diagram shows the performance of the data flow in the ARM processor. Now we came to last part of the topic, that is conclusion. The data flow diagram of an ARM processor illustrates the movement of data through its various components during instruction execution. Understanding data flow is crucial for optimizing processor performance and efficiency. By implementing data flow optimization techniques, developers can enhance the overall functionality and speed of the ARM-based system. So this is the diagram which shows the complete data flow diagram of the ARM processor and their techniques. Thank you.